Hi guys, welcome back. So we are still looking at a linear function and what it is all about, right? So now we're going to try and explore the actual linear function further and see what it is all about and see how do we draw this. I've shown you how to actually plot the points, join them with a straight line. Now we're going to look at some more concepts that have to do with the linear function. But for now, let's have a look at it quickly. Now, remember the linear function, the general equation is given by y is equals to mx plus c or y is equals to ax plus q. It really means one and the same thing. Just that some textbooks use m and c, some use a and q, but they really mean one and the same thing. Now the value of m or a determines the steepness of the line. Sorry, as I said, then the larger the value of m, the steeper the line, right? And then remember the negative sign will cause a reflection in the x-axis, right? Where the direction then changes. Now the effect of changing the m or the a, firstly, we need to look at which one is the main graph here. And the main graph, we call it the mother graph, where it is the y equal to x, right? Now I want to change this around. Changing it means that I must change the m or the a value, which is normally in front of the x there. If I make it a half, it means this becomes less steep, right? Because we did say the bigger the value, the steeper the line is. But now this is a small value from 1, right? Because if there is no value in front of the x, it means that is 1, right? So if there's nothing there, it's 1. Half of 1 is half itself. So that's why it is a bit shallow. But now, when we have y is equals to 2x, that is a bit more, so it becomes more steeper than the mother graph. And then y is equals to 3x, it becomes way more steeper than this. So you can see, this was 1, it became 2 there, it became 3 there, right? The m value or the a value. Remember we said they mean one and the same thing. So the bigger the value, the more steep it becomes. Right? But the smaller the value, the gentile it is. We normally use the word gentile, either steep or gentile. And then the value of c or q determines the shift of the graph up or down, right? So we do need to also know what the up and the down is all about, right? So it means if I have y is equals to x as the mother graph, when I say y is equals to x plus 1, the plus 1, because it's positive, it means I must move it 1 unit up, right? But in the very same posture that it is in the same nature it is in, you don't tilt it or anything, no. As is, you just slide it 1 unit up, right? If I say x plus 2, you slide it 2 units up. X minus 2, you slide it 2 units down, right? But I will show you this. But you won't be required to slide them in terms of the paper. No, you are going to write them down and analyze certain things. But you are just sliding it either up or down. That's what the value of C or Q really has to do with. Now, it also represents the y-intercept. We do know that, right? So if I had y is equals to x, it means my c is 0, right? Because remember, anything plus 0 will always be that anything, right? So it means this, the graph is at the origin. It is crossing through the origin point. But as soon as I make it x plus 1, it means now it is crossing at point 1. Right, on the y-axis. That's what it simply means. So that's why I'm saying you shift it 1 unit up, 1 unit down, 2 units up, 2 units down, depending on what the graph is. So remember again, my mother graph here will be y is equals to x. And then you can always move it up or down depending on what the value is. If I say x minus 2, now that simply means it is 2 units downwards, right? 2 units downwards up until it gets to that point. But as you can see, these two lines are still at the same distance between one another there, right? There's still the same distance between the two lines. Why is this important? Because as soon as maybe the distance here becomes smaller, it means that you would have tilted the line, and that's what will make it incorrect. So we say that these two lines are parallel to each other. It must just move at the same distance. Guys, a typical example of parallel lines will be a road, right? If you look at the road, the distance from this pavement to that pavement is the same throughout the road, unless it gets to a point where it's going to be maybe an intersection, or it's going to be now one lane instead of two lanes. But if it is still on a two-lane point, it will always be equal. If you draw a line there and measure it, it must be the same throughout. That's what we call parallel lines. So even with this, when you are moving it up or down, it must always still remain parallel to the mother graph, which is the y equal to x. Now, the second one will be when I move it upwards, which is y equals to x plus 3. So you can see, with this one, we said it crosses at minus 2 because the y-intercept is minus 2 there. But this is positive 3, so it must cross at 3. So the midpoint between 2 and 4, you can see there is 3, although this is in a scale of 2, right? So this is 1, 2, and then 3, 4 like that. So you can see it is actually crossing at that particular 3 there, which is important for you to know. Now, just to summarize what we've looked at, guys, and then I'm going to give you one more example that I want us to please quickly look at. A relation can only be a function if every input value has only, guys, the golden word here is the only one output value. If it has more output values, then you are no longer talking about a function. Now you are just talking about a relation, right? For that relation to be classified as a function, one input must always give me only one output. But it can happen that many input values give us one output value. That is the many to one. But that just simply means that it's unique input values that always yield one output value, but it's unique value. So it's always 1, 1, 1, 1, 1, 1. Although this one on the other side, the output value is the same throughout. So it's 1 to 1 and many to 1. As soon as it becomes 1 to many, it's no longer a function, it's just a relation. And then the linear function has a constant gradient and a constant y-intercept, right? So if now I had said to you, I want you to find the equation, right, which I'm going to write here. Find the equation of A, which has the coordinates maybe 2 and 5, and B, which has the coordinate, we can make this 6 and 9, maybe. Let's just make it like that, right? Remember what I showed you first in this lesson. We looked at if it's a graph and I'm trying to analyze the graph. Now, if I didn't give you the graph and I gave you points, how do you then find that equation? I need you to please think about that and think about it carefully, right? Remember I said the two most important things are what? The gradient and the y-intercept in terms of a linear graph. The y-intercept, it's easy to see it on a graph, right? When I gave you the Cartesian plane and draw the graph. The gradient, whether it's a graph or it's points, it doesn't matter because you always need to calculate it. So here, the very first thing that I know you are thinking about already will be to calculate the gradient. Calculate the gradient, right? And that will be y2 minus y1 over x2 minus x1. and then you plug the values in, which is something that you are going to do. The Y2, you can treat it as the B there. The ones, you can treat them as the A there. And then number 2 will be to substitute this. You sub this in the equation y is equals to mx plus c. And then I want you to figure out number 3. How do you then find the third point? What will be the third step that you need to follow there? And I'm going to leave that with you so that you can please just visualize this. Research, guys. I know that I've given you all the basics. Now it's some time for you to actually try work this out. And then we'll see it next time. But for now, I hope you've enjoyed what we've been looking at, guys. Remember, mathematics is food for the soul. If you do it well, I promise it will nourish every fiber in you. But the goal with all of this is just to understand the basics. If you do not know that, then you will not know the bigger things. So you need to know the smaller ones in order to make sense of the bigger things. Guys, from me to you, the Maths Doctor, I will see you guys next time. Mathematics is food for the soul. Until next time.